Alright then, welcome back. Here we are at Unit 2-3. We're still dealing in our textbook there in Chapter 7, but we're in Unit 2-3, our third lesson in Unit 2 here. So remember, if you see these, here's a little reminder for you. You've got your guide to watch, stuff to put into your notes, and some practice problems. Still in Standard 2.0. Today we'll learn multiplication properties of exponents. Multiplication properties of exponents here. So our vocabulary, coefficient. You don't necessarily need to write these down, just make sure you understand them if you need to draw a picture or add something in. The coefficient is the number multiplier of a variable in an algebraic term. So for example, if you have 4ab squared, the coefficient is this number 4 out in front. Okay? And if you hear somebody or hear me say exponential, it simply means an expression is written using exponents. Alright, remember that when multiplying numbers with exponents, if the bases are the same, just add up the exponents. So like we saw yesterday, 3 to the 4th power is just like this, and 3 to the 3rd power gives you 3 more. How many total 3's do you have? Well, of course we have 7. And we learned yesterday we can just simply add these two exponents. 4 plus 3 is 7. So have your notebook ready for this one. Let's jot a few of these down here. If we have y squared times y to the 4th, remember that parentheses around two expressions are going to mean that you're going to multiply them. How many y's are here? Well, there's 2. And how many y's are here? Well, there's 4 more. So 2 and 4 gives you, of course, 6, y to the 6th. Take a look at this one. What do you think? N to the 6th times n to the negative 2. 6, negative 2, if we add those together, then n to the 4th would be the correct answer. How about this one? M to the 3rd, m to the 2nd. Well, just add up how many m's you have. How many m's do we have here? We have 5 of them, so it's m to the 5th. What if we simplify this? This has 3 factors. You got x to the 3rd, x to the negative 2, and x to the 4th. So if you wanted to, you can add straight across, or you could add the positives and get 7 and subtract 2. Any way you cut it, you should end up with x to the 5th. And let's see. I'll do this one here, so just watch. So we're going to change this power to the people to something called power to the power. If we end up with an exponent raised to another exponent, this means the base here is 4 squared. 4 squared 3 times. So this exponent first on the outside here, we're going to end up with 4 squared times 4 squared times 4 squared. Well, how many 4's do we have? Well, the bases are the same, so we can add the exponents, and we're going to end up with 4 to the 6th power. And can you see a faster way of doing that? Instead of writing these bases out, what about this 3 and the 2? What do you think? Could we just simply multiply them? So 2 times 3 is 6, so we get 4 to the 6th. So a power to a power, if you see exponents stacked on top of each other, you can simply multiply them. Let's do this one together. Add this one to your notebook there. Y to the 2nd raised to the 4th. Well, let's see. We've got y to the 2nd 4 times. But what if we just multiply these two? What's 2 times 4? 8. So how about y to the 8th? How about this one? N to the 6th cubed. Well, let's see. I've got n to the 6th as the base 3 times. N to the 6th, n to the 6th, n to the 6th. You could break all those down if you want to into little n's and add them all up. Or you could just simply multiply. 6 times 3 is 18. How about this one? M to the 3rd raised to the negative 5. Okay. Nothing changes here. We're just going to multiply these two. We will end up with negative 15 as our exponent. But remember from our previous lesson, we're going to write this as a positive exponent. So it's going to be 1 over m to the 15th. Remember, ignore the negative sign, m to the 15th, and then write your answer as a reciprocal because of the negative exponent. And how about this one? 4 to the negative 2. So I'll give you a second to jot that down. 4 to the negative 2, and then we're going to square that. So it's going to end up with 4 to the negative 4. Go ahead and ignore the negative sign. 4 to the 4th power. Write your answer as a reciprocal, and that's good enough there. I think we just saw that. It's 1 over 4 to the 4th. Most of the times if you break 3 digits or get into 3 digits, we can write our answer as a reciprocal. Most algebraic terms contain a coefficient that may or may not be affected by the exponents. May or may not be affected by the exponents. So 2x to the 5th cubed. So in this case here, this 3 is going to impact everything inside the parentheses. Let's see, the 2 is not changed by the 5. So if we start on the inside here, it's going to be 2x to the 5th. It's not 2 to the 5th, just 2x to the 5th. And so we end up with 2x to the 5th times 2x to the 5th times 2x to the 5th. How many 2's do we have here? We have 3 of them. 2 to the 3rd power is going to be 8. And how many exponents there? You got, looks like 15 to me. So 8x to the 15th. So this 3 here is going to work on the 2 and x to the 5th, one at a time. So you just simply take this guy here, okay, and we're going to go 3 times the 2. That's going to give you your 2, your 2, your 2. There's your 8, okay? And then you can work on this piece here. 5 times 3 is, of course, 15. Okay? All right then, you try this one on your own. So leave your answers in exponential form. X to the 3rd raised to the 5th. So if you need to, go ahead and pause that and jot it down real quick. Did you end up with x to the 15th? That would be the correct answer. How about this one? B to the 3rd raised to the negative 2. Well, ignore the negative sign. 3 to the 2nd power there. You're going to end up with b to the negative 6. So how about 1 over b to the 6th? Sometimes you'll see them written like this because you'll see this in a computer program or written out in a linear fashion. This is 1 is the numerator, b to the 6th is the denominator. How about this? A little bit messier looking, but still be fine. You've got negative 4 x cubed, and all of that is going to be squared. So if we take this and we say it's going to be 2, and you're going to end up with negative 4 squared. So what's negative 4 times negative 4? And then you've got x to the 3rd squared, and let's see what you end up with here. Did you end up with 16x to the 6th? Might be tempting to put a 5 there. Remember, you're multiplying those two. How about this one? Looks like a negative sign on the outside, so we're going to ignore him for a second. Let's just work on the inside here. 2 to the 3rd, x to the 2nd cubed. All this is cubed here. So here we go. How about negative 8x to the 6th? Where'd the negative come from? Well, it's this negative sign hiding out front. How about this one? 5y to the 8th squared. Let's square 5. What's 5 times 5? 25. And then what do we do with this 8 and 2? We're going to add them, subtract them, multiply them, divide them. We're going to multiply them. So how about 25y to the 16th? All right. Consider the following here. This might help you a little bit if you've got some generic problem like n squared times n to the 3rd. See how they're sitting side by side? They're sitting side by side there. And when you write your exponents and you're going to consider what to do with them, what's the operation from elementary school that uses lines that go side to side? It'd be the plus sign. So you can add the 2 and the 3. But if you have exponents that stacked on top of exponents, now you're getting a diagonal situation. What operation uses diagonal lines? That's multiplication. So if they're sitting side by side, maybe you think of the addition sign. If they're stacked where they're kind of diagonal to each other, then you could think multiplication. So exponents are side by side, you add them. Exponents diagonal, we multiply. So that's it for Unit 2-3, and here's some information if you need some more, and don't forget to jot down a question there. All right then.